Very good afternoon, everyone. I hope I'm audible. Thank you for taking the time to join us for today's webinar on Quality 4.0 QMS implementation using live QC tools. We are glad to have you with us and look forward to sharing how our software can support your team in achieving better quality management through smarter and more efficient practices. EGS India was founded in 1993 by our MD Shri Natarajan Ramamurthy after his successful career at Ford Motor Company. Since then, EGS has been offering consulting in quality engineering, Six Sigma, and key processes like APQP and PPAP for top automotive suppliers in India. We have also supported medical device companies in resolving FDA notified quality issues. With branches in Coimbatore and Tirchi, EGS serves all of Tamil Nadu. This session will now be led by our MD, Shri Natarajan Ramamurthy. Under the live brand, we have been building software for PLM, quality management, and document management. We are proud to present this special session today. I hope it would be helpful for your day-to-day activity. Please feel free to note down any questions. We would be address them at the end. And now, I warmly hand over this session to our Nat sir.
Good afternoon to all of you. Thank you, Govind, for this introduction. We started EGS India with the vision of engineering development through effective partnership, followed by the mission of imparting leading-edge technology and training and development, new product development, problem solving through consulting services, and providing software solutions and technical support. EGS was started in 1993, as was told earlier. And recently, we launched the Live QC Tools software for the Indian industry and for the rest of the world. It's an indigenous software development initiative. Followed earlier, we had developed the Live PLM software. So what we are going to be talking about is going to be about EGS India first, followed by the Quality 4.0 paradigm implementation using Live QC Tools. EGS India has over 150 employees working in a lot of different areas in new product development and software solutions. We are the reseller of Dassault systems in India, and we carry significant experience in providing software, technical support, and upgrades. And we have been working with a lot of different companies in providing innovative product design solutions with the emphasis on cost, time, and quality as the paradigm. Having been associated with Bureau of Indian Standards for development of standards and upgrades of standards, as well as with organizations such as SAE, IPI, IMTMA, MMA, NIQR. We are proudly associated with all these companies, specifically in the area of quality and reliability paradigms. With over 2,000 customers, the breadth of knowledge that we have got over many years with experience coming along with the knowledge has helped us to develop these kinds of mainstay technologies. So the three business models what we have are engineering services, software solutions, and the technology training. We are known for our GD&T and tolerance tax calculations training provided to a lot of different customers, the DFM, DFA, the FMEA as applied to design and process. Now, in any quality department, the functional requirements are many. Significant ones of them are shown over here. It could be non-conformance, it could be a root cause analysis, it could be issue management, it could be audit, process improvement, many different things that come together under one umbrella. Typically, people use spreadsheets, people use PPTs to put things together so that they have MRM meetings to show the status and things like that. There are two things that we need to understand here. One is data is dynamic. Number two, all of these functional requirements cannot be standalone islands. They have to be interconnected, interrelated, so that one influences the other, and you are able to take a bird's eye view of the entire landscape while making a decision not based on an isolated data. So this is where Quality 4.0 comes into picture, where the emphasis is on digitalization. It is an afterthought for the Industry 4.0, specifically with regard to quality functions, because quality and reliability are gaining the mainstay in the industry worldwide, primarily because they are the ones which are required to be successful with regard to any product or service that we provide to our end customers. So when you connect all of them together, a better picture emerges and the data is dynamic so that you can make informed decisions based on the data that is available at that point in time. So the interrelationship between all this is emphasized in this presentation, which would enable you to transform from paper processes to paperless processes subsequently down the line. The essentials for any quality management system that is put forth as applied by ISO 9000 or any other standards are these 8 pillars, where the QMS that you implement in the organization are related to these aspects. When you digitalize each and every one of these pillars, this is exactly where your Quality 4.0 starts to bear fruit with regard to your organization. You could be dealing with suppliers, you could be dealing with customers, you could be dealing with internal team members, stakeholders, whichever way you look at it. At the end of the day, connecting the dot brings about a more efficient methodology for implementing a QMS, specifically with regard to the efficiency, the productivity, and ensuring that a mistake does not happen twice. So when you look at all these different aspects that we look at in a QMS, how do I go about digitalizing all of these? Before that, when we look at the key impact areas, you will be seeing that these are typically related to the quality management part of it. I think the slide is not moving. Yeah. The quality data management, the process optimization, the compliance management, the product development, and the supply chain management. While it may be impacting other areas, these are the areas where the influence of Quality 4.0 implementation is significant, visible, tangible, and brings in the ROI for any organization. So in day-to-day functions, the QMS, the way it goes about, you need to have the data collection and review of the data. Then the documents part of it, the records, the drawings, the reports, and things like that. Then the management of the issues, non-conformance, corrective action, preventive action, performing root cause analysis, reports, and things like that. And then the changes as applied to notification, update, and tracking. These are typically the daily functions that we go about. For some reason, the slide is going very slow. In digitalization, in paperless quality management, the dynamic data consumption, storage and retrieval, search, sharing, is very important according to the job functions in the organization. The past data and knowledge available is instantly posted, picking up the trends early on, improving the efficiency and the productivity, creating, managing, changing, obsoleting data as well as records with ease. These are the things which are making a paradigm when it comes to paperless quality management. Take, for example, a machine being used in a work center, and you are looking at the process for that particular machine, and the operator is using that machine. Is the standard operating procedure available online digitally for him to comply with? Can we look at whether he has complied with it or not? All these are part of online transformation of your quality processes, your checklists and things like that, so that you can get the data directly mainstream online. And if the SOP changes, the latest SOP is available with the operator or the consumer of that information. And second is the output of that particular machine. What is the control chart? What is the process capability? Where are we today as compared to where it was yesterday? All these things can be dynamically looked upon with Quality 4.0 when this transformation happens onto the platform. A simple example is what I'm showing you over here. Similarly, at every shift, you can look at what is the number of parts, what is the production, what is the number of parts produced, how many were rejected, operator-wise, shift-wise, how many were rejected, how many were reworked. So many different ways in which you can dynamically look at the data on the system, primarily because you don't want to be in a reactive mode. So intrinsically in any operations, when we are looking at activities that are being provided, the planning of the activities is the most important thing. While doing the planning of the activity, you go through the planning, the assignment of the WBS for every stakeholder in that plan, monitoring it and seeing whether it has been completed or not. Take, for example, your calibration. You are using an instrument for calibration. What is the calibration plan? Who is responsible for calibrating it? How frequently it has to be calibrated? What is the report that is coming out of the calibration? For example, you are looking at it in a gauge R&R, for example, or any other kind of things. In every one of this, when we are looking at these data, you put a plan together for every month as a repeatable process. Put the plan once, save it as a template, recall it, assign the tasks automatically. Just look at whether they have been completed or not. If they have not been completed, send a reminder message till such time the work is complied with. So what happens as a result of this? You know exactly that every task is being done for the importance that particular task has with regard to the entire quality ecosystem in the organization. If one thing does not work and you do not know that it was supposed to work and it has not worked, but the effect of it is seen downstream when the customer reports a quality problem, you do not know where to look for the needle in the haystack. But with this kind of an approach where everything is planned and tasks are provided and the people are getting about doing their work and it's being monitored, it helps not only improve the productivity and the efficiency of the processes, but it also eliminates firefighting when the customer comes back to you and reports to you a problem. Similarly, you can use planning for your APQP planning, and you can put the start date, the end date, the actual start date, the actual end date, the monitoring of that, and assigning the tasks automatically and getting things done, and also putting the deliverables together and making sure those deliverables have been attached at every milestones that the project planning is intending to be reviewed upon. So any one of these processes, you can be putting it as a part of your live Gantt, which is provided inside the software. Another example is a customer has provided you with a issue, and the issue is very critical, let us say. You can put it through an issue resolution plan. In the issue resolution plan, you can have different stakeholders coming in at different levels of the WBS, different actors coming in, performing their roles and receding into the background so that the overall issue can be contained, prevented, or corrected, whichever way you look at it. So this can be put as a template and be called on demand. And then even in audit, you have your planning, right? Audit planning, whether it is internal audit, external audit, customer audit, whichever way it is, put a plan together, execute it to the plan. And if the NCs have been raised in the audit, have they been complied with or not? Everything can be seen online. ISO 9000 2015 expects the customer who is employing the QMS to be vibrant to the customer response, to be agile to the customer response, to be risk aware to the customer response. So every bit of the way you need to look at each and every one of them, you can put risk templates in it and you can assess your suppliers as well. So like that, live audit provides you with methodologies to do the audit for every different section in your organization. So the most important thing in any planning is the activity being associated with the person and the task being provided to the stakeholders, whether those tasks have been completed, delays are there, you can look at it or you can see as an overall dashboard view. When you do this, you can use it for production planning, you can use it for quality planning, you can use it for your gauge R&R. Any which way you want it, you can look at it, you can assign the tasks and get things done and see whether they have been done or not, completed or not. This is as far as planning is concerned. Typically, firefighting is what we do in quality, right? Whenever we get into trouble with either the customer reporting a problem or we have a supplier quality issue, whichever way you look at it, at the end of the day, we have to sit with the customer or we have to sit with the supplier and solve the problem together. In that, the teamwork is absolutely more important than the individual importance for the individual, because teamwork is what delivers at the end of the day. For example, in root cause analysis, let us say an issue has been reported. Now, you can put together an issue template the way you want it, according to your company's practices. This is a sample that is shown over here. These are all user configurable. You can put this together and you can raise the issue. You can provide additional data as and when required. And then in this particular case, it's a case of a premature bearing failure in a swash plate pump. You can attach the images of those failures directly on the carousel there itself, so that this information is available in posterity long after this problem has been solved, so that if somebody is looking at this data subsequently down the line, either in design to prevent a failure or in manufacturing to ensure that certain quality parameters are verified, then the things will not slip between the fingers. So this knowledge repository comes as a result of making this available online to stakeholders as required. So you can do an 8D analysis, give it to the different people with tangible start dates, end dates, actual start dates, actual end dates, putting a plan together and getting the 8D problems, justifying the 8D solutions, doing a root cause analysis. And mind you, in every one of these causes, you can attach either documents, data, charts, or anything to make sure that you see that it is working. This is not a fishbone which shows you only the root cause with regard to the cause and effect diagram. Every one of them you can click and you can get the information what you want with regard to the data repository associated with that particular cause. So at the end of the day, when you do an AD report and you submit a report, it could be a configurable report according to your customer, according to your practices, according to whichever way as a supplier. You can put the reports together and you can have it as a template and reuse it effectively every now and then. And it's a knowledge sharing platform of past things gone wrong, which have been corrected not to go wrong again. And it's easy to monitor. So eventually, subsequently down the line, when the data that has been put into the system has achieved a maturity level, then introduction of AI is beneficial, not at the state where we are just going about implementing. So in the long map, when everybody is asking, will the software give you the information? It has to learn. For learning those information, the repository has to be built. If not today, at some point of time in the future. When you go to Google and you search and you ask for an information, it gives you the set of websites from which it has taken the information and provides you with the answers. Those are the data which is available for the AI engine to learn from and provide you with intelligent answers. Since root causes and data are confidential to an organization, they cannot be shared with the general ecosystems across multiple companies because competitors could also be there. The island of information that you have needs to be put to use for the AI engine to learn from. So the precursor for that is Quality 4.0. Now, if I look at the knowledge base, you have the ERP, you have all the part information sitting on the ERP, the metadata. You can bring in the relevant metadata onto the quality management system in Live QC tools. There are different tools available for you to bring in the data. And for example, you can take a part, you can attach the images over here, any kinds of images over here. And then you look at the part nomenclature, which you would have brought from ERP over here. The advantage here is all the transactional information is available on the ERP, while actionable data and information is available on your QMS. This is the difference. For example, you look at the tab left top corner, you will see the design checklist, you will see the feasibility. Now, for this part, what was the design information checklist that was used? I will zoom in a little bit for you to see it so that you're able to see it. So you can put a checklist like this together with the responsible person with the due date and proof any, attach it whatever way you want it. These are all configurable inside the Live configurator. The versatility of the Live configurator can be seen from all these different types of data that can be put inside into the software. So have all these been considered as a part of design process? When you put a process in design, quality for that process has to be monitored as well, right? Otherwise, the things gone wrong will finally come to haunt us subsequently post-production and launch with the customer. So has the design department looked at all these aspects? Yes. Who has looked at it? What report was attached? Everything comes into picture. We are looking at all this information from a quality paradigm. Now I take this information and I go to a supplier and I ask him to do a supplier feasibility study. I can have multiple suppliers, multiple feasibility studies. Putting this together and getting the production feasibility agreement with those sign off with those suppliers before you sign off on that particular part. Similarly, under that part, you can attach your issues with regard to that part. internal issues, external issues. 80 reports for that part. Any which way you look at it, you can, in some parts you may have it, in some parts you may not have it. Whichever way you look at it, you put it together. For example, a process FMEA for that particular part is attached right there. So you can look at the SOD, severity, occurrence, and detection. You can see how those have to be monitored, how things can go wrong with regard to that, attach those data right there itself. All these are template driven. So the DFMEA, the AAGVDFS templates can be put inside the software so that you can configure it the way you want it and attach it for your boundary diagram, for your QFD, every one of those cases. I'm just showing you a few here. Now, when you look at the warranty of that particular part, for the same part, you can look at the warranty and when it was last updated, how current is the data. You can look at the distribution of the issues that you got with regard to that particular thing geographically. It gives you a bird's eye view. And data of this kind, when seen, gives you actionable information. So any which way you look at it, you will be in a position to get all these quality related documentation and data directly on the system. And you can look at what are the different types of warranty problems that you have had, and using the observation and the action, what action you have taken, and you can put the proof there itself. Take the reports directly from this. Whenever you do it using a PowerPoint or an Excel or anything else, the data is static. Here, the data is dynamic. So the report is a snapshot of the data at that particular point in time, who has taken the report, when, and the copy of the report writes inside the system. So that you can look at the previous reports as well. Now, any process that you put together, you have to define the process. This is the heart of any quality management system. You have to collect the data, you have to analyze it, and then improve it. Now, in this picture, whatever you're seeing over here, you see the different areas. For example, this is a production methodology for a part. You start, you inspect the casting which is coming in, and for any visual defects, and you put those in the inspection rejection bin. You click on the rejection bin, go back. On the right side, you are able to see the rejection bin data over there, and charts are there. When you go in there, you double click on that. You tell you all the different kinds of rejections that you can have. You can put your knowledge repository into the image console there, so for other people to look at it. And then you see the defect analysis for that supplier. What was the kind of defects that have come in, which are significant, which are insignificant, and then take actions based on that. This is directly driven by the process. You can put the process as a template, and you can repeatably do it for how many ever parts you want, for how many ever suppliers you want, and collate all that data, put it as a dashboard, and then put that template, put the data dashboard as a template, and view it dynamically for every supplier, morning, afternoon, evening, whenever you want. Now, for example, this is a simple bird's eye view of operator-wise NC based on the data that has been put over there. See the power of information that is coming out of the system, because every stakeholder is putting data into the system according to that person's role and responsibility. It's like a knowledge repository, a library. So you can get as much as you want, depending on as much you put inside the system based on what the stakeholders are putting inside daily data. Okay, this is, for example, cost of scrap, the rejection cost. You can easily monitor it, map it, put it together, put a template together, take it from ERP, different sources of data, collate it and put it together. And rework cost similarly. So you know exactly where your money is leaking. So the actionable analysis is the word to go. You put the processes together, you are dynamically putting things together, right? the actionable analysis is where things come into picture. For example, you look at this circuit board. You want to look at the defects which are coming in. You have a process, you have put everything together. Now you are having defects coming in, and you want to do a defect analysis of this electronic assembly based on the defects reported by the consumers. I go back and put the Pareto chart directly on the system, and this Pareto chart can be made dynamic so that it keeps changing dynamically every time the input data is changed. You can take a report on a particular day, but then you can keep it dynamic as well, right? So as you go through the number of defects, one is the lead causal indicators have to be looked upon. You send a notification through the notifier inside the software to whoever the stakeholders are. It should be a cross-functional team. It could be an individual. It could be a combination of any of these, and tell them this analysis has to be performed. I have put a task together. Please do this. We need to reduce the number of defects on this. After they do an analysis, see 8D report is also being asked by the person to do it, by the team to do it. And then a corrective action plan and a preventive action plan. Once you have put this together, you do a fault tree analysis, because you want to make sure that you isolate the flaws and they don't come again, right? And then you put together what is called as the preventive maintenance checklist. Now, once the preventive maintenance checklist is put together, person sees it and says, okay, daily what needs to be done, weekly what needs to be done, monthly what needs to be maintained, half yearly and yearly. So the maintenance plan is very clearly laid out over here. Whether this was adhered to or not, you can put a task over there and see whether those people have adhered to those tasks and provide evidences if required. Similarly, in this particular example, the failure was as a result of electrostatic current being passed. So the SOP was changed and the conformance to process audit was initiated. Now you put this together and the operator has to say day 1, day 2, day 3, day 4, whether they have complied with it or not. Random inspection will be done. Layering, remember layering. That will be done so that random audits can be done by other stakeholders in the organization. And then you will see whether this conformance is achieved or not. So like this, actionable processes can be put together inside the software. So this is where the platform comes of use. In addition to that, you have the records management, where all the quality related records, the evidences, the reports, the issues as coming from the customer, the AD reports that need to be provided to the customer, anything, spreadsheets, any document can be attached and put inside, and you can classify it according to your business processes, group it according to your organizational hierarchy, make it granular at the user level, who can access it, who can read, who can access, who can write, when will that access be removed. All those things, the user can do it at his own level or her own level. It need not be driven by IT alone. So, and then obsolescence control, by removing the validity date, instantly it becomes obsolete. The previous version cannot be touched except for the author who can review it. The rest of the people cannot touch it. They will know that the document is there, but they do not know, they cannot access it. So obsolescence becomes an instantaneous implementation. And then the version control, the trail history, the feedback and the action taken for those records in terms of who is responsible, who is accountable, who has been consulted, who is informed. The RASI can be done, and then the evidence is attached. And in posterity, even after 10 years, you can look at the data and bring it back. The secure access can be provided according to the organizational policy. Typically, implementation of these kinds of tools and technologies helps you in increased agility in response to your customers' call, customers' requirements, customers' requests, customers' actionable item points in your MOMs. And then it improves your efficiency of the organization by itself. The entire ecosystem moves up because each person knows exactly what they need to do and what is the deliverable, when is the deadline, everything. Improved quality is a mainstay, enhanced collaboration is a no-brainer, and better decision making because of informed data being available. In summary, Quality 4.0 gets enabled primarily because of the platform level approach, either on premise or on the cloud, according to your choices. And it's a proactive control instead of a reactive control. And you can put your quality assurance procedures and you can make sure that people have been able to adhere to those procedures in a timely manner or not. I have not showcased the many tools which are available for the brevity of time. In further webinars, we will be showing each and every one of them for the benefit of the people who are looking at implementing these kinds of tools and technologies. And the advantage is the continuous monitoring of either the supplier or the internal quality or the production processes or any process for that matter, reducing the overall cost of ownership while improving the reliability and enhanced trust. With regard to this, we have recently launched this program. We invite you to look at and evaluate the software for your requirements and look at all the different ways in which this can be put together for your mainstream requirements. The QR code is provided here. You can contact us or you can visit liveqctools.com and provide an evaluation request, and they will be able to handle your requirements accordingly. We encourage you to look at all these things, and if the